Greetings and salutations. All right, so this video is on 13.2, talking about angles and angle measure. Let's start off by talking about angle measurement. So one of the things we have to be able to do is draw angles that are bigger than 180 or negative angles, anything like that. So when we're asked to draw an angle in standard position, the first thing that we have to understand is there's a difference between what's called an initial side and a terminal side. The initial side is simply the positive x-axis. And then the terminal side would be approximately where that angle would end. Okay? We have positive angles. Positive angles are going to move on the coordinate plane. They're going to move counterclockwise. And negative angles are going to move clockwise. All right, so let's jump right in and take a look here. For example, if I wanted you to graph a 210-degree angle, the first thing I know is its initial side is always going to be this positive x-axis. Now, I know that if I travel counterclockwise 90 degrees, I'm on the y-axis. Well, 90 is not enough. I need 210. If I travel all the way to the negative x-axis, I'm at 180 degrees. Again, I need more than that. I specifically need about 30 more degrees beyond 180. All right, and the way that I can indicate that this is a 210-degree angle is I show kind of a little arrow curve, if you will, that shows where I started and where I end up, the terminal side. Okay, how about negative 45 degrees? Well, that would give me an initial side at the positive x-axis. But because it's negative, I'm going to now move clockwise around. So negative 45 degrees is going to go and be somewhere around here. And I indicate that it's a negative 45-degree angle by drawing a little arrow there to represent how I moved from the initial side to the terminal side. Okay? What about one that's like 540 degrees? Well, 540 degrees, we're going to start with an initial side right here. If I were to go all the way around back to the initial side, that's 360 degrees. So I know one turn of this would take off 360 degrees, leaving me with, how many degrees would that be left? That would be 180 degrees left. Okay? Now, again, I'm back at the initial side. So if I go 180 more degrees, now that takes me out this direction. So it looks like a 180-degree angle. But how I can represent it as 540 degrees is I start and rotate all the way around using this little symbolic way of representing. That's how I move to get to 540 degrees. Okay? Now, the next thing we're going to talk about is we're going to start to talk about this thing that's called the unit circle. Unit circle, very simply, is in the coordinate plane. We have a circle that has a radius of 1. So I know my circle is not going to be perfect here, but you get the idea. We have a circle of radius 1. In other words, this circle exists at the point 1, 0, the point 0, 1, the point negative 1, 0, and the point 0, negative 1. All right? And when we start to measure around this thing called the unit circle, we have the ability to now change how we measure by looking at what's called degree measure versus radian measure. So another way to write a degree measurement, an angle of a certain degree, is to write it in radian measurement. Okay? Now, what we're going to be asked to do first, this again is just an introduction. We're going to be asked to change from degrees to radians or radians to degrees. All right? On your calculator, remember we talked about this earlier in the year, that in the mode, you might have to change your mode from radian to degree or degree to radian, depending on what you're trying to do as far as a particular type of execution of something. Okay? But today's stuff, like I said, is really easy. Okay, so we're going to change from radian to degrees or degrees to radians. I notice that I am given a degree measurement, 60 degrees. To change that to radians, according to what I had up there, I'm going to multiply by pi over 180. So if I take pi over 180 times 60, this gives me 60 pi over 180, which I can simplify that fraction to be pi over 3. So 60 degrees is the same thing as pi over 3 radians. How I know I'm dealing with a radian measurement, most of the time, it's going to have pi in it when they're talking about the measurement of an angle. All right, what about negative 30 degrees? Well, again, to change from degrees to radians, you multiply by pi over 180. And this would give me negative 30 pi over 180. All right, and then if I simplify that, let's see, that goes in, so this would be negative 1 pi, or negative pi, over 6. All right, now what if I wanted to change from radian measure to degree measure? All right, the beauty is what I'm trying to do, and this is how I always remember it, I'm trying to get rid of the pi. Okay, so instead of multiplying by pi over 180, I'm going to multiply by 180 over pi. All right, when I do this, I notice how the pi's are going to cancel each other out. I have 7 times 180, and I'm going to divide that by 4, and that tells me that this is the same as a 315 degree angle. All right, if I have a radian measurement of negative 5 pi over 3, I'm going to change it to degrees, I'm going to multiply by 180 over pi. Or in other words, I'm going to take negative 5 times 180 divided by 3, which gives me a negative 300 degree angle. All right, the next thing we're going to talk about is an idea of something that is called coterminal angles. Now, what coterminal angles simply means is angles that have the same terminal side. Angles that have the same terminal side. All right, remember, all angles, when we're dealing with these angles in a coordinate plane, always have an initial side of the positive x-axis. But the terminal side totally depends on where they end up based on the degree or the radian measurement. Okay, if an angle is given to me in degrees, to find angles that are coterminal with it, I'm going to remember to either add or subtract 360 degrees. That takes me one trip around that thing that we talked about called the unit circle. Okay, if I'm given an angle in radian measurement, I'm going to add or subtract 2 pi in order to find coterminal angles, because 2 pi is the same as one trip around the circle. Okay, so for example, it says here, find an angle with a positive measure and an angle with a negative measure that are coterminal with each angle. All right, so the first thing that I look at is I say to myself, for 210 degrees, is that in a unit circle? Yes. So I know in order to find another positive, I have to take 210 and add to that 360, which gives me a positive 570, has a same terminal side as 210 does. It's just I took an extra trip around the circle. All right. An angle with a negative measure would be take that 210 and subtract 360 from it, and that gives me a negative 150 degree angle. That's it. So we're going to either add or subtract 360, depending on the scenario that we're presented with. So what if I have a 400 degree angle? Well, I know that 400 degrees has already done one full trip around the circle and then some. So whenever I have 400 or something larger than 360, I'm going to get it back to that first trip around the circle by subtracting 360. In other words, I know that 400 degrees is exactly the same terminal side as a 40 degree angle. And then I take that 40 degree angle and I subtract 360, and that's going to give me my negative coterminal angle, or negative 320 degrees. All right. Okay, so let's look at number 3 here. So this is an angle that's given to me in radian measure. I know that because pi is in it. I also notice I have the fraction 7 over 3. I know that 7 over 3 is greater than 2 pi. All right, so this is more than one trip around the circle. What I'm going to do to find these two measurements, a positive and a negative angle that have the same terminal side, is I'm going to either add or subtract 2 pi. Now in this case though, I'm going to take 7 pi over 3 and I'm going to subtract 2 pi, which is really 6 pi over 3, and I know that pi over 3 would be an angle that shares the same terminal side. Then I take that pi over 3 and I subtract 6 pi over 3. Again, that's 2 pi. And I know that a negative coterminal angle would be negative 5 pi over 3. So what if I had an angle like negative 3 pi over 4? Well, negative 3 pi over 4 is already negative, right? So I need to find another negative and a positive to go with this. For negative 3 pi over 4, I'm going to try to first find a positive one. I'm going to add 2 pi, which is really 8 pi over 4, and that takes me to 5 pi over 4, which tells me that has the same terminal side as negative 3 pi over 4. For another negative, well, I already have the negative 3 pi over 4, but I'm going to subtract from that 8 pi over 4, which is going to take me on another trip clockwise around the unit circle, and that takes me to negative 11 pi over 4. Hope this helps. Let me know if you guys have any questions on 13.2.